So this brings us to some techniques. So we're going to start off by talking about prediction and how we can use branch prediction to determine two things, the outcome and the target address. So branch prediction. Everyone always thinks that it means this first thing. That's not what it means. It encompasses both things. You have to predict the outcome, so that's whether the branch is taken or not taken. And you also want to predict the target address. Now, if you think about that, the first one sounds relatively trivial. I could just sort of pull numbers out, or I could pull something out of a hat. Taken, not taken. Just sort of choose randomly. It's going to do OK, probably. I could probably try to correlate it somehow, use some heuristics. The second part here, I have to get the number exact. So if I choose at random for my branch prediction outcome, I'm going to get a 50% right. Or if I just always choose, I don't know, we'll say we would just always choose not taken or something like that. We're probably going to do pretty good. But getting the actual destination correct, you have to be exact. You have to choose a number out of, let's say if you have a 32-bit instruction pointer, you have to choose some random number out of 2 to the 32 locations and get it right all the time with high accuracy. So we'll spend some time about this, talking about this and some strategies to getting the prediction target and predicting our branch target and our jump target correct. But you have to think about both of them, is all I really wanted to get across here. OK, so this is something is a little bit more review from something we had talked about in lecture, I think, 2. We talked a little bit about figuring out where we can resolve a branch. So here's a little bit longer pipe. 1, 2, 3, 4, 5, 6 stages. Not quite our 5-stage pipe. I put a issue stage in here. And let's look to see where everything gets known. So we know that our target address for branches, jumps, and jump and link will likely be known here. But that's not really helpful unless we know which way the branch is, or rather, unless we know which way the branch is going or the branch outcome. Because even if we know, at least for jumps and jump and links, we know the outcome. It's taken. But for conditional branches, we may not know that until somewhere over here. So we can't necessarily use that information until later in the pipe for branches to do something useful in the naive approach. In the execute stage, we know the branch outcome. We talked about a trick in MIPS at least, where you can try to pull that forward a stage into our decode stage by having some sort of special comparator on the output of a register file, comparing it with 0. But that doesn't work for all branch types. So if you have something like a branch equals, where you're actually trying to compare two real registers, you have to wait for the full bypass. Doing a 32-bit compare is sort of the equivalent of doing a full 32-bit subtract. You're not really going to know that until the end of the execute stage. That trick doesn't really hold water. It holds water for comparing with 0. You might even be able to do it if you have lots of extra time in your decode stage. But let's assume that you don't. Also, target addresses for jump registers and jump and link register. Jump registers, jump and link register, you need to read the actual address that you're going to out of a register somewhere. So this, you can't even have a chance of trying to predict it out here, or the destination. It's pretty hard, because, I don't know, it's somewhere in the bypass, you just compute some value, then you jump through it. So we don't, at least out in here, by the time we're done here, we have one of two addresses, we have both of the addresses that the branch could potentially go to. It could go to either the fall-through address or the branch target. And we know that's sort of at the end of the decode stage. For jump and link registers and jump registers, we don't even have that information. It's not encoded in the instruction anywhere. It's encoded in a register. So we need to go fetch something from the register. It might have to go through the bypass network. So we're going to have to wait.